Good afternoon, everyone. Previously we are mainly talking about the product of VFD, and today I will introduce the INVT control product, and I will mainly focus on the TX600 Series PLC. The topic about the presentation is about TX600 product technical training. And the presentation, there are three parts. First one is about the control product portfolio. Second is about the introduction of TX600 PLC and Flash I/O. And the third part, we'll mainly focus on the third part, the Auto Station Pro. It's the programming software of TX600 and which is developed by INVT itself. So you can see this list is the INVT control product portfolio. So first part is about the HMI. Currently, I only mentioned two series. First one is VSQ series. Actually, this is our main series of HMI. And for the new customer, we will recommend this series, which has much competitive price. And second series is VK and VT series. For this series, actually, we only recommend to our old customer because this is old series. Some customer, if they want to keep purchase this series, and we will give them the correct type. Because the thing is, for these two series, they have two different programming software. For the VS, it uses HMI tool for the programming, and for the VK and VT, it uses VT designer. And the thing is, the program cannot confirm from HMI tool to VT designer, so it will be very complicated for a customer if they purchase two different series. So next is about the INVT PLC product. So currently we have medium and large PLC. Currently, medium PLC is AX series. This is the type we are currently selling. For the AX series, we have both CPU type for NPN and PMP. And maximum it can support 32x via Ethercat communication. So the main motion control is via Ethercat. And TM700, this product is also medium PLC. So this is still under development, and in the near future, it will replace AX series. So these two are our medium PLC series. And TP6000 is large PLC, so it is suitable in application with multiple, with the X more than maybe 128X. It's used in a big system, but it actually is seldom used. And for the small PLC, IVC1L is our old series PLC. You can see the design, the value is a little bit bigger actually. And we have launched new TX600 series PLC. But now the GPU type is limited. The first generation is only about NPN output. And for this series, it can also support Ethercat communication. So customer can also use this series PLC for the motion control, for some ECAM and gearing function, and also interpolation. And actually, I just got news from product 9. They have developed PMP type CPU for TX600. So now, if the customer, especially from Europe, if you are interested, we can apply for a sample machine with PMP output type, and you can have a test. And for the I/O, First one is AE. AE series actually is used with the AX series as default, but it is remote I/O. So it means the communication protocol is EtherCAT. So if the PLC it can support EtherCAT, then it can connect with this AE series. This series is about 32 input and 32 output for the I/O. And the Flash I/O is our new series, and it can support, currently it can support 3 different communication protocol. The first one is EtherCAT, a second is Profinet, and also third one is Ethernet IP. So for the Flash I/O, you can use Siemens PLC. You can also use like a Rockwell PLC. So it's also suitable for like Europe and American market. Later, I will have detailed introduction for the TX600 and the Flash I/O because these two are our new product. And for the server, as I introduced this morning, so currently we are mainly focused on DA180 is the economical one, and the DA200 is the most common one and for general purpose. And in the near future, DA180A will replace part of the market of DA180 because it's up to 1 kilowatt. And the DA200A also is up to 7.5 kilowatt and will replace part of the market of DA200. And we also have some special system. You can see we have DL series. It's for the DC input server system. You can use in some application like AGV. And also we have dedicated solution for hydraulic server system. MH860A is also our new server system. And next, I will have a detailed introduction for TX600. This is our new design small PLC, and it has high performance, the logic control, the motion control, and also we will have an IoT solution with an IoT extension card. So for the performance, for the CPU, it can support 1G May frequency, and for the bit operation, is 0.01 microsecond, and it supports backplane bus 100 Mbps, and for the I/O refresh rate is 125 microseconds. And for this PLC, it's using compilation type. So the compilation, the speed, the processing improve so much, you can see, comparing with the interpolation type. The IVC1L is used the interpolation type. And another performance is about motion control. So because our old series IVC1L, it doesn't support EtherCAT, but in this TX600, it has built-in EtherCAT communication. So for the EtherCAT, it can support maximum 32x for the motion control. And for the 16x synchronization, it can up to 1 millisecond. And it also supports 8 channels of single-phase high-speed counter. And for the pulse control, it can support 4x for the pulse control. And also for the motion control function, for the ECAM, for the interpolation, we have a standard function for the TX600 series. So in some cases, comparing with old series IVC1L, it has the more smaller value, more compact, and high performance. And this for the collection. So for this is taken TX635 for example. It has standard 2 channels of RJ45 port, and it has standard 2 channels of RS485. And for the expansion, it can support RS232 and also can open communication. And also for the Modbus protocol, it can support Modbus TCP, UDP, and Modbus RTU, and also EtherCAT. And for the programming, I mentioned just now, use our new platform. It's called AutoStation Pro. So with this programming and software, we can have some functions like one features is for the motion control for the communication and pause. It uses same function block for the programming, so it will be easy for our customer to make the programming. And also it can support graphical configuration, and operation control can support graphic blocks. And in this software we also add C language for programming, because for some complicated calculation it will be easy for the C language. And for the expansion card, currently we have 3 different expansion cards. First one is about RS232 can open, and the SD card. And second is the 4G and the SD card. And third one is about the Wi-Fi and the SD card. And the second one is about the local expansion. So the local I/O model actually is same with Flex I/O. So Flex I/O can be the local expansion model of TX600, and also can be the remote I/O connect with the Cooper for the communication with other brand of the PLC. And for the local, it can support 16 local expansion models, no matter which type it is, the digital input, digital output, analog input, analog output, and the temperature model. And for the CPU, for example, TX635, it has standard 16 digital input, 16 digital output, and support 8 channels of 200 kHz high-speed input and output. And for the EtherCAT slave, it can support maximum 72. So in this case, it has very good expansion features to connect with like a remote I/O, and to have the expansion for the I/O. And this is for some IoT functions. So it can support VPN remote downloading programs, and also support cloud such as MQTT and API. Currently, for our general inverter like GD100 PV or GD350, if to connect with the IoT, usually we need another IoT model. We have it called ICA model. So within this model, for the 4G model, you insert the SIM card and configuration, and you can control and monitoring via a website or phone app. And actually it's the same logic, just it becomes an expansion card to insert in this part. It's a card, but no need external models. This is the comparison between old series IVC series and TX600. Some customer may know the IVC series, actually, we used to have 4 series, IVC1S, IVC1L, IVC2, and IVC3. And this year, we stopped other series and only left IVC1L because currently we only have 5 different types for the CPU. And for the relay output, actually TX600, the CPU doesn't support relay output. So in these cases, if customer they need a CPU with relay output, they have to choose IVC1L series. So first, the point is about the performance. So the processing due to the improvement for the DSP. So it has good processing speed for the instruction. And the second one is about the communication. The IVC series only support Modbus CAN open and Ethernet, and it doesn't support Ethercat. So it's very hard to realize some motion control function. And next is about the value. You can see from the picture that the IVC1L is like a bread type, and TX600 is more smaller value. So this is the 5 different CPU types for the TX600 series. The first one is TX611. So for this type is for the serial port. So you can see it only supports 2 channels of 485. It doesn't support Ethernet, and it doesn't support Ethercat. So in these cases, customer can use the Modbus for communication and also for the pulse control. And the second part is about TX621. So the difference is it adds the Ethernet port in this type, but it also cannot support Ethercat. And we have 3 different bus types. 633, 634, 635. So the functionality and similar. The difference is just in the Ethercat bus. You can see 633, it only supports 8x for the Ethercat communication. And for the 634, it can support 16 for the Ethercat. And 635, it can support 32. So there's some difference between those CPU series. So next is about remote I/O, our Flex series I/O, which has the same design with the TX600 series. So you can see this is the Flash I/O series For the communication Cooper, we have EtherCAT and Profinet and Ethernet IP. So you can use with many kind of PLC brand. And for the basic model, now we have the digital input model, digital output, analog model, and temperature model. And also for the encoder model, we have just developed for the encoder model. And in the future, we are planning like pulse model and node sending model, node cell model for the winning for the packaging application. And these some features for the flash I/O. So first one I just mentioned for the backplane bus is 100 Mbps. And for the reliability, so you can see it has the gold plating process, resists all kind of corrosion, and it has long life guarantee. The entire series adopt 3 resistance coating to prevent dust, salt spraying, and meeting the wide range of the operation conditions. And they can use in -20 and 20 degree for the temperature range, and at the altitude of 3,000 meters. And another thing is about the value, comparing with our old AX series. This is counting for the 16 I/O models. It has 64% reduced for the value. And it's easy to use. In the side of the model, we will have the diagram, and also we have the QR code for the electrical manual. And for the connection, we make the modification for the terminals. So it's brushing terminal, so it's easy for the wiring connection, and it's easy to identify because we use different color mark for different expansion model. And for the arrow regularization, each arrow has a status indicators, so you can see intuitive for the arrow of each model. And for the maintenance, if the terminal is broken, you can just remove the terminal directly. And also, if the model in the middle is broken, you don't need to remove the model or the model. You can just remove the model in the middle to replace a new one. So it's very easy for the maintenance. So this is the all types for the flex I/O. So you can see we have EtherCAT, Profinet, Ethernet IP. This is for the communication Cooper. And for the digital input, we have 16 input, 32 inputs. And for the output, we also have 16 output, 32 output. And we have different types for the PMP and the NPN. This is for the extension model. And we have model can support both input and output. And we have relay output model. The CPU doesn't support relay output, but we have relay output model. And also we have the analog model, the temperature model. So this is the all available model.
Do we have 8-channel analog input? 8-channel analog input?
Analog input?
8-channel.
8 channel, no. We are not playing 8 channel, only 4 channel. And the last part is about the AutoStation Pro. I think just some of you has already installed this software. and I want you to have some acknowledgement for this software, and after I finish this presentation, I want you to install this software and to make some programming to have a test. So this is the main interface of the AutoStation Pro. So the top is about the menu bar. It's for create a new project and debugging and PLC connection with PC. And the right side is about the product manager. So the programming is in here for different programming, sub-programming, and for the communication configuration, for the expansion model configuration is in this way. And in the middle is the programming area. And the right side is the instruction tray. You can find, sometimes if you don't remember the function name, you can find in the instruction tray. And in the bottom is the message output window. So basically, this is the main interface of the AutoStation Pro.
Simple question, does it support offline-online programming?
Not yet. We are developing this function because some customers they don't have the PLC inside in office, and they can use the offline simulation function. Yes. Yeah. I think maybe in the third quarter of this year. Yeah. Yes.
About, I'm talking about of remote I/O flex.
Mm-hmm.
I/O remote.
Mm-hmm.
You have the two options: Ethernet IP, okay,
We-
and Ethernet.
Actually, three options.
Yeah, three.
Yeah.
For TS, can I use both Ethernet IP and Ethernet?
At the same time?
At the same time of the processing. At the same time, use both.
Yeah, theoretical is okay. But you know, if the PLC support Profinet, normally it cannot support Ethernet, and normally it's the same situation in like VFD in one application. If you use Ethernet for the motion, then you cannot use Profinet.
No, in this case I will use Ethernet IP.
Ethernet IP,
Yeah, not Profinet.
Ethernet IP and Ethercat.
With TS.
Mm-hmm.
If I have TS, I can use
Uh,
IP. Okay?
you mean TS600 CPU with Ethernet IP model?
Two
Yeah.
interfaces.
It all depends on the CPU. Currently TX600 only support Ethernet IP for the slave, but not for the master. Yeah.
Slave.
Yes, so the Ethernet IP model actually is developed for the Rockwell PLC.
Okay.
Yeah, not for the TX600.
So the TS is a
Mainly for Ethercat.
slave. TS. Is a
For the
slave.
Ethernet IP is
Yeah,
slave.
for Ethernet IP is slave.
Yes,
For Ethercat is
it can be master. Yes.
yeah.
So the flash I/O if used with the TX600, so it only can be the Ethercat communication. The Ethernet IP and Profinet.
Only for Siemens and
And for the PLC which can support Profinet or Ethernet IP.
Yes, and one question again. Sorry. TS600 support ring topologies or not? Ring topologies redundant. Or we need use the
You mean downloading the program?
ring topologies for reservations.
Reservation?
Between each other with two PLC or not support. Yeah, it's like close standby, yes.
I don't get you.
I don't understand, yes?
Yeah. You mean two TX600?
Ring topology, okay? We have a two PLC. example TS600.
Mm-hmm.
Two PLC operations, one, the second states redundant. If the one ring is broken, line.
Oh, you mean redundant function? Currently low, yeah, low. This is not supported so far. We know that Siemens PLC has this function, but now TX600 doesn't support this function. Yeah. Okay, so for the programming language, basically now it can support ladder and instruction list, and SFC and C language. And for the ST, actually we are developing this, and at the end of this year, and we will have a first version of ST language. So next is the soft elements for the AutoStation Pro. For those are the regular one. The difference with the previous one is we make the I take M register for example. From M1000, it is saved in memory after power off. So it is in a retain area. So you don't need to set which registers will be saved after power off. And this is for the variables custom. And it can only contain like underscore, letters, numbers, Chinese character. It can and cannot start with the underscore and numbers. And it cannot have the same name as soft elements, constant, standard data type, and instructions. And also it cannot use the keyword, some like an array, like on, off, null, like this. And this is how it defines the array. So choose the type and the length of array variables. And then you can define the name of the array. And if you use in a program, it's like this. Like for example, I define Apple as an array. So if you can use there are two members in the array. So it will be in like Apple 0, Apple 1, like this. And this is the struct differentiation. It's similar, but different uses you can see. If I use the members of the structure, it would be like fruit dot apple, so like this. And also we have some system variables. So this is already defined in software. And so if you communicate with Ethercat, we will have an Ethercat status like for the system variables like this. So you don't need to define by yourself. You can just find in the software.
All the individual IO card status will come, healthy, failed, in the system status.
Mm-hmm.
Can we get the individual IO card status, healthy or failed?
You can model.
IO model.
IO model.
IO model, healthy status.
Yes. IO model, you need to like install a configuration file for the IO. Then you can check in the configuration for the status. You mean if there's an error, you want to check the status of IO, right?
If IO card failed, analog card is failed.
Mm-hmm.
My customer want to know in the HMI, this IO card is failed.
Yeah, then you can define variables for the IO status. Then you can read the error code of the expansion model, then read to HMI.
PC module also? Temperature module also?
Yes, same. It's the same. Yes, all the extension model. And this is about program download and upload. So currently there are two methods, two ways. First one is USB. So on the USB, now almost the port of the USB is Type-C because it's very popular now and also in the future.
Only for download and upload, yes?
Yeah. To connect PC with the TX600. And the second way is for the Ethernet. So there are two ports of the Ethernet. You can use port 1 or port 2. So both ports are available. And this is about an online modification. So online modification, it means because usually if you are monitoring the program, you cannot modify anything. So this function is to modify when you are monitoring and you find some fault, you can modify and then download. And also we have already add trace function. So it's like in a scope. You can monitor some values of some registers. And also the log file function. This function is to read some error from the PLC and then the status from PLC. And the PLC clock function. So this PLC never low battery inside, but without battery it can keep the RTC function for like 3 or 4 days. But if customer they want to have a long time for the RTC function, they can add external battery, because nowadays it's very hard if we export the devices with battery for every country. So in TX600 we remove the battery. And for the firmware upgrade, because in some cases you need to modify the firmware to fix some problem. And the old series INVT is actually it's very hard to update the firmware because it needs special tool and the updating method. So we make an improvement in TX600. We can just connect to PC via the USB or Ethernet. Then we will send you the latest version of the firmware. For example, now latest version is 1.39. Currently it's the latest version. We will send you maybe to fix some bugs. And the C language, as I mentioned, the C language is mainly used for some complicated calculation for the mathematicals. And this is just basic instruction for the how to use the C language. So firstly, you need to add the source file. So here I define it name of B, so it is M resistant. So this is what I write in the C language. So I write the B100 equal 1. So when I call in the program, you can see in the right side, when I call the C language as text 1 as M0, so it means if M101 is collected, then M100 is collected. So this is the use of the C language. And the next is the comparison. It's the same programming in the C language, but I call in a different M resistance. Just now I call M0, now in this program is M10. So it means if the M112 11 is collected, then M100 is collected. 110. 110 is connected. So in conclusion, the real M resistance is dependent on the program which M resistance you call in the program. If you call M0, the real one will be 0 at 100, so it will be M100. So if you call M10, so the real one will be 10 at 100, so it will be 110. So it's like this. And another thing is this is basically for the addition calculation. So for the addition, it's similar. First, we add the sources to define 3 different variables for the data 1, data 2, and data 3. And then you call in the program. Here is D200, D202, D204. So the thing will be D200 will be the addition of the D202 and D204. So this is just the basic introduction for the C language, but it can realize more complicated calculation. And for the this is the example for the communication for the Modbus TCP. So Modbus TCP, you know, TX600 can be master and can be slave. So here is the example for the slave. So TX600 as a slave and to connect with VSQ HMI. Actually for the TCP, because this our product, both PLC and HMI are from INVT. So in HMI, we will have dedicated drive for TX600. So if it's also possible to connect with other brand of HMI, but you know, some HMI, they don't have INVT drive. Especially you can choose TX600 Modbus TCP. Actually, you cannot find this option. In these cases, you need to select the general drive, like for the Modbus TCP slave, or for the, like in some brand like Panel Master or Modicon. So here, for the Modbus TCP connection, in PLC setting, you know, for the Modbus, the key point is in IP. So for the PLC setting, the default IP address for the Ethernet 2 is this 2.10, and for the Ethernet 1, the default is like 1.10. So in the software, you just need to enable the slave configuration and to check. If you don't want to change the IP address, you can just keep it default. And here actually there is enable control element. So in case that there is some conflict between port 1 and port 2, you can set different M resistance to enable the function of the Ethernet. So here if you set like M0 for the enable Ethernet 2, so after you connect with the M0, then Ethernet 2 can work like this. And in the HMI setting, as I mentioned, because it's INVT HMI, so you can find the option INVT TX600 TCP. After you choose this option and set the correct slave address, you can use the soft element directly in HMI. For example, you write D1000 in the PLC, you can also write D1000 in the HMI. So you don't need to change, because for some connections, there might be some offset for the address. But in this way, if you have the corresponding drive, you don't need to worry about this. So this is simple example. If I move two value in PLC program, so like I move 10 to the D0 and move 100 to the D10, and in the HMI you just have the property as the correct data type for D0 and D10, then it will show the same value. So this is the connection between HMI and PLC for the Modbus TCP. And the next example is about the Modbus RTU. So the example is take TX600 as master, so GD27 as slave. So for the Modbus RTU, actually it's not, it's a common setting for every brand. For the Modbus RTU, the parameters would be address, baud rate, speed, stop bit, track, and parity. So in this case, you can see in PLC setting, because PLC is as master, so you just need to choose Modbus RTU master, and
time to responsible for answer.
sorry.
Time to responsible answer. If you have a master, if you have a loose connection between your devices, slave, you need to second times to read some Modbus.
Yeah, you mean timeout time?
Timeout, yes.
Mm-hmm.
Yeah, but you're not set about it.
This is just for testing.
Just simple question is, should we set baud rate and other parameters specifically to something like connected to the TS, if they be same like odd, even, or
Yeah.
9600 baud rate or something like this, should it be clear, like specific, or if they are same, I mean HMI parameters and the TS parameters are same, is it okay? Or?
Yeah, it should be okay for the parameters I just mentioned.
Communication parameters, I mean.
For the baud rate, the parity track, for the data bit, stop bit, it should be same in the master and slave. Yes. So this is the setting for the this is the master PLC, and for the slave, take GD27 for example. Actually for all general inverter is the same for GD20, GD350. Firstly, you need to set the snap address. You can just for first one is communication mode. If you set communication mode, then it means it will control by the communication. You can use the Modbus for start, stop like this. And second is about the frequency given, the frequency resources. The normally given by the keypad, and you can also choose analog, but in this case it's communication. And for the 14 is about an address and baud rate, stop bit, track. These parameters you need to set the same as the master. So this is basically the parameter setting for the Modbus RTU. And next example is this is the after the set the communication parameters, then how you read or write the parameters in inverter. So here you can see this is the window in the PLC. So to read or write the parameters of like inverter or slave or any slave devices, the communication is via the address. So we need to get the address of the parameters you need to read or write. So here is a simple example for the, you can see this is the address for the Modbus. So you can maybe you know the address of our inverter showed in menu. You can see make 3000 hex, 3002 hex. So the address of our inverter is hexadecimal. So but in this PLC is use the decimal for the write or read. So firstly, you need to find out which parameters you want to read or write, and you get the hexadecimal address of the parameters first, and then change to the decimal, and then you can just give the
Convert to decimal, not change to decimal.
not change it.
Hex to convert to decimal.
Mhm.
I cannot do that.
You cannot change by yourself, right? Yeah, you can by calculator. It's easy. yeah, by calculator. So here is an example for like this. I think is the bus voltage and also the frequency of the inverter. So and then you choose the read or write. Usually for read we use 0.3 for the function, and for the single write is 0.6. For the continuous write is like 16.
If communication is not done, any error in value register? If communication is not done, so can any error register value?
Status of communications of your. If you have error communications, what's the register number of this status? If you have communications error, correct?
Yes. Communication is not done.
It's not done. You cannot read the value.
So any register value for?
No.
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 Connect, because
Yeah,
you
because
don't connect.
only after the communication is established, you can see the value.
Yes, only for established.
He's
Established
asking
connections.
Error code,
If you
error
don't-
code.
You have error code.
No, you don't
Oh.
connect to device.
Error code, you can see, yeah, you can see. If the communication is not established, you can see the error code. There is a flag bit for the, special for the Modbus RTU. For different kind of application, there is a special resistance or information for the, like an error code. You can check, okay, if it is value of this, it means the Modbus doesn't establish like this. Yes, because in this way, actually, if you want to check, you can set all the parameters, and you set like parameters to read. If you cannot read, usually it means the
Yes, you not read this.
yeah. Usually, if you cannot read the value, it means the communication is not established.
The point is, communication is established, supplying to customer, one drive is issued. One drive or one component is issued. We want to know in HMI, this communication has failed. So we need to take status from the PLC.
After the establishment, before the establishment.
Yeah. I understand you.
After supply.
Yes.
So you can find a corresponding resistance to like which, for example, you connect one HMI with like two devices. If one is okay, another is not okay. Yeah. You can. You have for each communication there should be some flag bit or some status. Yeah, you can set and read.
And error codes. Error codes, it means for the.
It's not on the
Error codes, name of the communication is.
error code, right? You mean?
Yes.
Yeah. Different error have different meanings, so you can find out what's the problem like this. So this is the Modbus example, and this next is about the EtherCAT. So EtherCAT, the configuration. Firstly, we'll talk about the single X control. So first step is to import the XML file. So for different communication, for the EtherCAT maybe it's XML file. For the Profinet maybe some GSD file. So this is dedicated for different devices. First is to import the XML file. This is because later in the demo we are using DA180A, so it uses the same XML file of DA180. So the version will be 1.15. So firstly, you need to import the XML file. And then this is for the master configuration. And this is for the X. So after you add the EtherCAT and you add the EtherCAT X for the page, you just select the output device. So it means you already add the motion control X for this DA180. And then you can just use the function block for the EtherCAT motion control. Here is a simple example for the MC power. Is for the enable the servo drive. Yeah, and the second some motion functions like move relative is for the relative position control, and also other like move absolute is absolute position control, and also move velocity is for the speed control. So it depends on the real application. And the MC stop is to stop the motion X. And just now is the single X control. So next is about the multiple X. Here is the example for the gearing. So gearing basically is the slave following the master with same speed or same speed ratio. So it's the similar way you add 2X for the EtherCAT and the motion control X. And the servo enable also is same MC power. And firstly, for the master and slave, firstly you need to enable the master. Here use the move velocity to let the master running in a fixed speed. And then after you trigger the MC gearing, and then the slave will follow the master with the speed ratio. You can set one same ratio or 10 times ratio, 5 times ratio, like this.
Can we configure encoder as the axis one and one servo following some gear ratio?
Encoder. Then then it's not via the EtherCAT. It's using the diffusion frequency output. It's also possible from one server to another. Yes, with the differential outputs. That's for the pulse control, not for EtherCAT.
So,
Yes.
one question. Can I ask yes?
Yes.
So, if I want to establish the communication with slave device, AutoStation Pro has a library with used the sound template for installed and settings, or I need to create.
You don't need to create. For example, just now I mentioned
Library.
this is from library. You can use it directly in software.
Of course, yes.
Yeah,
Yes, okay. Not created.
not created.
Yes,
It's in the existing
just
library.
for prop and settings.
Yes, yes,
Okay.
yes. Later I will show you in the laptop.
Okay.
This gearing function will follow the actual velocity of the first servo motor or the set point.
It's like following the master with same speed or with the set speed ratio.
Actual speed it will not take. It will take only set speed or actual speed from the drive.
Mm-hmm.
It will take the feedback from the drive and follow the second speed or
No, set speed, because the speed is with this move velocity function. Yes, this speed.
if we want to take the actual speed, what to do? I need to follow the actual speed of the motor. There may be some variation.
That's the like the diffusion output. we just mentioned, it's not fire EtherCAT. Because EtherCAT, the speed is the set speed in this function block. Yeah. If you want to follow the actual speed, you need to, with another way. Yes.
In velocity move some velocity to different velocity, it's like zero, so not zero.
Mm-hmm. The acceleration?
Acceleration is working.
Yeah, it's working.
But,
In the function block.
no, distillation is working also.
Yeah, sure. Because I know what you mean in EtherCAT server, right? EtherCAT in EtherCAT server, the acceleration and the deceleration is same parameters. You want to set separately, right?
Set separately.
You need to use the non-standard software of server. Currently, for the standard software, the acceleration and deceleration is same parameter. If you want to set separately, need to download the non-standard software. Yes, but it is available now. Some of our customers already asked this. Yeah. So for the gear in, after you trigger the gear in, and the snake will follow the master. And the gear out, you can just stop the snake. And the MC stop is to stop the master. So this is the function of the gearing. So this is a last example for the, I take this example to show the functionality of the pulse, because just now I mentioned the function block of the pulse control is same with the motion control for the EtherCAT. So in this case, we're trying to realize the function like TX600 control the GD27 inverter file terminal control, and the frequency given by the high-speed input of the HDI-A of GD27. And in this way, we need to use the pulse output function of TX600. And so we need to make a configuration for the pulse in the software. So the difference is the X type. So in this way, we need to choose the local pulse type. So just now, for the EtherCAT communication, we choose bus type. So for the output, pulse output, we choose local pulse type. And we choose the output device for the Y output. Here we use the Y0. And in this way, to control the inverter, in the program, firstly, we use this function block to give the frequency of inverter, and we will run with the Y5 of the PLC. So basically, with this example, you know how to use the pulse control of the TX600 and how to make the terminal control between TX600 and the GD series inverter. So this is all the presentation for the TX600. And next I will show the programming. I'm not sure whether you have installed AutoStation Pro. None of you. If you take your laptop, yeah. But I want you to all to try by yourself. Yeah, because just now, just now, all the examples I've talked in the PowerPoint, I want you to try by yourself in the lab. Yes. So if you have your take your laptop, I will have the software, right? You install. If you don't have, it's okay. Our colleague can borrow you.
And can we export the tags from PLC?
Mm-hmm.
Can we export the tags from PLC and import in HMI? Export tag, import in HMI.
You mean the tag function?
Export.
For the TX, no. For the AX, there's a tag function. Huh? Topic of TS600. So I will show the programming interface of TX600, and later we will go to the lab to do the programming. Okay. So the main topic will be the what I talked in the PowerPoint. Okay. So please go to your seat. Okay. Hello. Please go to your seat. Okay, have a seat. Okay. So as you can see, later you can choose to install this version of software in your PC, or we can borrow you from our colleague, borrow the PC to you, and you can make the programming. So this is the main interface, and firstly we need to create a new project here. And in the demo system, as I mentioned just now, we have 5 different CPU, and in the demo system there is TX635, and we choose this, and we make a name. We choose the location, and we have a name. Testing. And then you click OK, and then you go into the main phase. So this is the main phase of the software, and we will the operation topic is about the those part. So first would be the C language. Okay, so for the C language, so firstly you can find in the project manager. Here is user C language, so you can add source file here, and you can have the click here, add. Then you add the resistance here, and click OK. Sorry? Okay. Okay, so later we will focus on those topics we are just talking about. Okay, so first topic is about user C. Okay, user C language. So first we find the user C language here in project manager, and we add the source file. Okay, source file. Yes, and you have the file name here. You name, because later you need to call it. So you name it like test 1, and you click here add. So you will add the registers here as name B and as byte, add M register, then click OK. And then you go to the programming interface of the C language, okay? And you can program here as an example. B100. So like this. And then you call in the main program. You can drag in the toolbar, or you can type in the keypad. Okay. So the programming. It means if you call the program as M0, so when M110 is corrected, then M100 is corrected. So you just read this to the program. So I will take an example. For example, I will type LD M100 and move like 1, 2, 3 to the D400 and LD M101, and I need to call the program C language, so I just type call the text 1 as M0. So it will be the same with the example. So if you here you write M0, so because in the C language you write as M100 equal 1. So if you write like this, means if M0, if the C language is executed, so it means M100 is corrected. So it will be like this. Okay, so this is the example. I will have the quick introduction for all the topics because I have already made the examples, and I will show you how to configure it and how to program it, and later you do the same in the lab. So first about is about the C language. This is about the M0 M100, and the second part is about the addition calculation for the 3 data. It's like this. So you can call. This is the first call the first C language, and this is for call in the second language like this. Second C language. And for the next is about the Modbus RTU. So Modbus RTU, firstly, you can find here in the COM. Here, so COM1, COM2 is 2 channels of RS485. You can open his add configuration, then you will have this table, and you just this function is for read and write. So 03 is read, single or multiple, and 06 is about write single resistance, and 16 is continuously writing. And after that you input the address, the Modbus address of the function codes of the VFD. Just now you see, if you cannot calculate by yourself, we can use calculator. Yeah. So here I write this number. Yeah, you can see. So this number 12285, you can see in hexadecimal is 3001. So hexadecimal you can find in the menu. I think it's the set frequency. So this is the way how you change the Modbus address. Okay, after you set here, so it means you move this value to the D0 and move this value to the D2, and then in the program Modbus RTU, you can just use this value and you can get the value, or you can see the value. You can use D0, D2 in the monitoring table. So this is another way. And for the TCP, because the HMI is connected with the TX via already via the Modbus TCP. So you can read all these data in the HMI. Later I will show you. Okay. So for the TCP, same here. You can find here I use Ethernet 2. So you can find I enable the function of Modbus TCP slave, and I set M55 to enable this slave function. So you can see in the programming, after I connect with M55, then you can use the snap function. And the IP is this. Then you just set the correct IP in HMI. So in the operation later, you don't need to set HMI because I already set it. Okay. So this is for the Modbus TCP, and for the HDI. So in this part, the example is to show how to use the pulse control function block, and how to connect inverter with PLC via the terminal control. So here, this is SM0 means always on. Okay, so you can ignore it, and if you connect with this function block, the velocity is set by D200, and this function is to change in the frequency during running status. Means if the inverter is running, you can change the frequency in HMI. So this is the terminal control to the inverter. And also for this part, you need to set some parameters in inverter. The first one is P00.02 is the control mode because it's terminal control, so you need to set it 1. And also for the HDI is 0 because it's for the high speed pulse input. So this is something. And also for the frequency given, it's given by HDI. So you need to set 00.06 also. And for the also I've made the gearing function. So this is enable, and this is for the master X for the speed control, and this is speed change, gear in and gear out, and this is MC stop for the master. And also I also made the program of ECAM. The difference between gearing and the ECAM function is the gearing is following the master with same speed or speed ratio, but ECAM function it can with different curve. So you need to plan in the curve of the electric cam, and then it can follow this curve. later, if you have time, you can also try it. So basically, those are the main topic for the operation. Okay. Okay. So now let's go to the lab and do some operation. Okay.